Welcome to AEL, where we make electronics easy to understand. Today, we are focusing on one of the most important electronic components, the BJT transistor. We'll cover what it is, how it works, its types, biasing configurations, and real-world applications. Let's dive in. A BJT, or bipolar junction transistor, is a semiconductor device used to amplify or switch electronic signals. It's called bipolar because it uses both electrons and holes as charge carriers. BJTs are made of semiconductor material, usually silicon or germanium, with three regions. Emitter, heavily doped and supplies carriers. Base, very thin and lightly doped. Collector, moderately doped and collects carriers. There are two main constructions. NPN, negative, positive, negative layers, and this is its symbol. PNP, positive, negative, positive layers, and this is its symbol. Each BJT has three terminals, emitter, E, base, B, and collector, C. Here's the basic working principle. A small current applied to the base emitter junction controls a much larger current flowing from collector to emitter. The base current is like a tiny control signal that regulates the base current flow. This is why BJTs can act as amplifiers. There are two junctions inside. Base emitter junction is forward biased. Collector base junction is reverse biased. This unique biasing allows current gain, meaning a small input controls a big output. BJTs come in two main types. NPN, current flows from collector to emitter when base is positive. PNP, current flows from emitter to collector when base is negative. NPN is more common because electrons move faster than holes, making it more efficient. As a switch, when the base current is zero, the BJT is in cutoff. When base current is enough, the BJT enters saturation, allowing full current from collector to emitter. This is how BJTs are used in digital logic and microcontroller circuits. Let's take an example with an NPN BJT used as a switch. Say we have a collector resistor RC, base resistor RB, a load. Let us use a simple LED. Emitter current equals collector current plus base current. Base resistor equals base voltage, base to emitter voltage, LED voltage divides by base current. Collector resistor equals collector voltage, LED voltage divides by emitter current. Since we are powering an LED which required current control, emitter current equals maximum LED current equals 20 milliamperes. Let's choose a base current of 10 milliamperes. Note that for turning on a BJT, maximum base current is 40 milliamperes. It is advised to keep the current lower than 20 milliamperes. We will use 12 volts collector voltage and 5 volts base voltage. Base to emitter voltage is 0.7 volts for silicon BJT. Forward voltage using a red LED is 2.2 volts. Calculating the base resistor gives 210 ohms. Collector resistor gives 490 ohms. Biasing is applying correct voltages for proper operation. There are three main configurations. 1. Common emitter. Most common, used for amplification. 2. Common collector. Works as a voltage buffer. 3. Common base. Used for high-frequency applications. Why biasing matters? Because without correct bias, the transistor won't work in the desired region, cutoff, active or saturation. BJTs are used in audio amplifiers, switching circuits in microcontrollers, oscillators, signal processing, current regulation. Even though MOSFETs dominate digital electronics, BJTs are still crucial in analog circuits. Let's try to simulate our example on Pro Tools. Let's select our component and build a schematic. So, we use a switch to demonstrate current flow to the base when turn on and turn off. So, when we turn on the switch, current flow to the base of the BJT turning it on and allows larger current to flow from collector to emitter turning on our load. When switch off, no current flow and our load is turned off. And that's your complete guide to BJTs. If this video helped you, hit like, subscribe to Alpha Electronic Lab,